Hello everyone, welcome back to another Cranky Calculus video. This is your Cranky classmate here with the Unit 8 review video. But before we get right into it, make sure to like, subscribe, and hit the bell icon to never miss another video. So let's start with this FRQ here. We're given two functions, f of x and g of x. So part A asks us to find the area of region R using these functions. So that's this part right here. So the first step to doing this is to find where f of x and g of x are equal to each other, or where they intercept. So that would be these 2 points. So to solve for that, we would just simply set the functions equal to each other. So we would just do ln of x equals to x minus 1 squared. And we could just plug that into our calculator and use second trace intercept to see where these two functions equal each other. And you'd get x is equal to 1 and 1.746. And now we have to find the area of R. So the formula for an area between two curves is just the integral between b to a of f minus g dx. So what this formula essentially means is that to find the area between two curves, we use the function on the top, f, subtract the function on the bottom, g, and just integrate that between those two bounds. So we would just do 1.746, 1, and ln of x is a function on the top, and then x minus 1 squared is the function on the bottom. And we just plug that into our calculator and we get 0.088. Another trick is to find this point here. When you use trace on your TI-84, it automatically saves the x value that you calculated on the graph. So if you just type in x instead of 1.746 on your calculator there, you would still get the right answer. And it's better to use exact numbers rather than truncating that to get a more precise answer. And right here our answer would be 0.088. Alright, so now let's move on to part B, which asks us to find the volume that results from revolving R about the line y equals 3. So if we just graph y equals 3 on our graphing calculator, compared to these two functions, y equals 3 would be a lot further up. Let's just say it's above, right about here. It's a lot higher than than the region R, so that's all we need to know. So when we have revolutions of solids, we think of two things, disks and washers. So a disk is when the entirety of this region touches the line, and a washer is when part of that region does not touch the line. So in this case, a majority of region R doesn't touch this line, so we know that this is a washer question. So the formula for calculating the area of a washer is pi and then big R of x squared minus small r of x squared dx. So what big R and small r are is the distance from the line, the bigger radius and the smaller radius in respect to the axis of rotation. So the bigger radius would be this section right here, and the smaller radius would be this section right here. And we would be revolving that around the line y equals 3. So setting up the integral, we would just have pi and then 1.746. We still use the same exact intersection points. So big R here would be this little section. So what that distance is would be 3 minus x minus 1 squared, because it's just the distance from this line to the point at x minus 1 squared. So let's just write that down. And we're subtracting little r, which in this case is 3 minus ln of x dx. And once again, that's just that distance right here. That would be little r. So when we compute that, we get 1.540. And once again, for this bound right here, the top bound, make sure to use like an exact value and not to truncate it, because that will give you a slightly off answer and you could get that question wrong. So just be careful there. Okay, so let's move on to part C now. So what it's saying is that we have a vertical line x equals k within this region, and the region got split into two equally sized subregions. It's asking us to set up the equation, but not to solve for this equation, to solve for k. So essentially what's happening is we have the region R, and there's a vertical line coming through it at x equals k, dividing it into two parts. And it's just asking us to find what this k value is for the vertical line. So basically what we have to do is take the entire area which we solved for in part A and set that equal to the left subsection or the right subsection. So either the area from 1 to k, which is right there, or the area from k to 1.746, which is right there. So I'll be doing it using the left subsection, but you could do it with the right one. It doesn't really matter. So the setup would just be from 1 to k, the integral of ln of x minus x minus 1 squared dx. And that's just using the formula for area, which is just from two functions, just the one on top minus the one on bottom, and the integral of that, and set that equal to half of the total area, which is 0.746 1 ln of x minus 1 squared dx. It doesn't tell us to actually solve for k, so just save yourself the time, and that's all you have to do for this question. Last but not least, we have part D here. So let's just look at it. Let R be the base of a solid where the cross sections of the solid taken are perpendicular to the x-axis are semicircles. Set up but do not solve for the formula to find said volume of the solid. So we know that the formula for volume is just b to a of x dx. And a here is just the area. So since we're using semicircles, that's just 1/2 pi r squared. So here, how do we find the radius is probably what you're asking yourself. But in these questions, the diameter is the distance between both functions. So it's just this right here would be the diameter. And to get the radius, we would just divide that value by 2. So just writing it out, the radius is equal to 1/2 ln of x minus 1 squared, which is just the distance between the top function and the bottom function. So let's plug that back into our area right here. So we just get that area equals 1/2 pi, and then this value, the radius, squared. And let's just call this a of x. So to get the volume, we would just do from the same bounds as earlier, that won't change, 1.746, 1 to 1.746 of a to the x. So that's just 1/2 pi ln of x minus 1 squared over 2 squared dx. And that would be your answer. Just clean that up a bit. Boom. That's everything for the FRQ. Now my esteemed colleague will be providing you with more knowledge in the MCQ section coming up right after this.
Let's go ahead and look at this multiple choice section for our Unit 8 review. If we number 2 here, we have the average value of a continuous function f in the interval from 0 to 10, and that is 5. Then the integral from 0 to 10 of 3 f of x dx is. So let's go ahead and use our average value formula. So that's going to be 1 over b minus a, integral from a to b, and I'm just filling in the blanks here. That's our average value formula if the a value is 0 and the b value is 10. And we know that in this problem this is equal to 5. Okay, so this says that 1/10 of this integral right here is 5. So when we solve for this integral, let's go ahead and multiply both sides by 10. When we do that, we're going to get the integral from 0 to 10 of f of x dx is 50. Now that's not what the question's asking for. The question's actually asking for 3 times this, because this is the same thing as 3 integral from 0 to 10 of f of x dx. So I'm going to multiply both sides by 3. That's going to give me 150, and that's going to be that 3 integral 0 to 10 of f of x dx. So the answer here should be C. For the next one right here, we do have some calculator work. I'm going to go ahead and show everything on Desmos. So when you do see this problem, you'll see everything done on Desmos. We're going to go ahead and find the approximate volume generated by revolving the first quadrant area enclosed by x plus y equals 2 and y equals x squared. There's a parabola, by the way, in a line. And the y-axis about the x-axis. So real quick, I'm going to sketch this. And if you have no clue how to sketch this, I'm going to use Desmos as well here in just a second. But here's your axes. We know that this, I'm going to underline it in purple, is a parabola. So this parabola looks like right here. And then this right here in red is going to be a line. That's a line of y equals 2 minus x. So it's going to go have some type of negative slope here. And then this is about the y-axis as well. So the y-axis is, I guess I'll do that in green right here. So that's going to give me this little shaded in blue area right here. And I need to revolve this around the x-axis, which is right here. So what I need to do here, and I can zoom in a bit for my picture, is I need to find this this volume of this little chunk, this blue chunk right there, being rotated around. Now we do have access to Desmos, so this is the graph right here. So this would be the little blue chunker right here. Okay, I did type everything over into the left, so just can get a visual of this. But I'm going to go ahead and do most of the setup, and then I'm just going to use Desmos as the final plug-in here. So what's going to happen here, since I'm rolling around the x-axis, I'm going to have 2 different radii. I'm going to have first the red radii, which is the big one, which is going to be 2 minus x. Okay, if I'm revolving around the x-axis, I'll do this in orange. I'm going to go from that axis I'm rotating up into the furthest away function, which is going to be red. That's why I use the red radius here as my big R. And then I'm going to go ahead and do little r now. And that one's going to be purple. So using a little r, it's my smaller radius. And this is going to go be just x squared. And I can know that. Again, my partition here, I'll do this in pink. Pink partition going from the axis of rotation upward until I hit my first graph there. So for the first one, it's my furthest one. It's big minus little. The purple one is my littler radius. So our volume formula, it's really nice to know what that thing is. So our volume formula is going to be the, it's going to be pi times the integral from my x-axis right here, or sorry, my y-axis here all the way to this intersection point right here, which I don't know that. I can actually find that intersection point by going right to Desmos, and it's 1, 1, so actually it's pretty convenient. So it's going to go integral from 0 to 1 of my big R squared, so it's going to be 2 minus x. It's not look much like a minus sign now, does it? It should be 2 minus x all squared minus x squared, and that should also be all squared dx. And all you do from here is you're just going to go ahead and type this integral into Desmos. And of course, how my thing right now is, you can't really see me typing it in on the left hand side. You'll be able to see it here in a second. So you can see part of it, 2 minus x, and that's all squared, minus x squared squared is x to the fourth. You wrap everything up nicely. And that's going to give me an answer of 6.702. So I'm going to get an answer of C. The big thing here, I trust y'all to use Desmos. The big thing here is just knowing how to set it up with the big R and then the little r. So it's always big minus little, and we always draw from the partition going towards our further away object for the large R, and then axis of rotation up to the closer part. Okay. All right, let's go on here to number 4. We get a little bit of particle motion. Particle moves along a horizontal line so that the velocity at time t is given by, we have our velocity function right here. What is the average speed of the particle on the interval from 0 to 2? So average speed here is really just going to be and this is no calculator, by the way, that's going to be 1 over 2 minus 0, integrate from 0 to 2 of the absolute value of our velocity. Now what's nice here is this is an upward parabola. That is always positive. So this is actually going to equal 1/2 0 to 2 of 6t squared dt. And this is a nice easy function here to integrate. I'm going to keep that 1/2 on the outside when I do integrate 6t squared. I'm going to get t to the third, divide that 6 by 3 to give me a 2. And we're going to evaluate that from 0 to 2. If you notice, that 1/2 and 2 are going to cancel out. So we're going to get t cubed, evaluate that from 0 to 2, which is going to give me 2 cubed minus 0 cubed, which is going to give me an answer of 8. So it's an average value question, really. Next one, find the volume of a solid whose base of solid is a circle of radius 1 and its cross section perpendicular to the x-axis is a square. Again, really helps for you to draw this out. Okay, so we have S, which is a circle. So I'll do that right here. Not the best circle, not the worst circle. This has a radius of 1, and so it's important to know that our equation of a circle here is x squared plus y squared equals 1. I'm trying to find volume, x-axis, perpendicular x-axis is a square. So what that means is I need this partition right here, this blue partition, is actually going to become a square. So I do need to solve for y real quick. Y squared is equal to 1 minus x squared, so y is equal to plus and minus square root of 1 minus x squared. Just so you know, this top part right here is the positive square root, and this bottom part right here is the negative square root. So when I try to find this partition, I have to do the square root minus the square root right there. So the whole blue partition here, which is going to represent our side, is going to be the square root of 1 minus x squared minus the negative square root of 1 minus x squared, and which is going to give us 2 square root of 1 minus x squared. And that's our side. And to find the area of a square, that's just going to be s squared. So, and don't forget, all we're trying to do here is we're trying to integrate the area. And so we're going to integrate our area from -1 to 1 because we have a circle of radius. Circle of radius 1 here. So we're going to integrate from -1 all the way to 1. So in this case, this is going to be the integral from -1 to 1 of 2 root 1 minus x squared, and that is all getting squared dx. Which is going to be a 4 integral from -1 to 1. I'm actually getting ahead of myself here on a little bit of a shortcut I want to do. Of 1 minus x squared dx. I'm running out of room here, but 1 minus x squared is an even function, so I can actually integrate from 0 to 1 and just double what I have. So this is going to be equal to 8 integral from 0 to 1 of 1 minus x squared dx. Holy cow, did I not give myself enough room here? I'm going to actually keep integrating on this side over here in red. That's going to be 8 times the integral of 1 is x minus, looks like 1/3 x cubed. I'm going to go from 0 to 1 there. When I substitute those numbers in, I'm going to get 8 times 1 minus 1/3, which should give me an answer of, that should be 2/3 times 8. It's going to give me 16/3 as my answer for this problem. For our next problem, we do have the calculator available to us. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t. And you can see it right there. If, that's a big old if right there. The position of the particle is x equals 2 when t is 4. What's the position of the particle when t is equal to 1? So if we're trying to find the position and we're given the velocity, we need to integrate the velocity to get to the position. So we can integrate v of t dt. And we're going to go from 1 to 4 because I have 1, or I want 1, I got 4, and that's going to give me x of 4 minus x of 1. I can do this integral in the calculator here in a second, but I do know that x of 4 gives me that value of 2. So this integral value is equal to 2 minus x of 1. If I'm trying to solve for x of 1, I don't want to add x of 1 to both sides, subtract the integral from both sides. So x of 1 is 2 minus this integral from 1 to 4 of v of t dt. So now we're good to go. We can set this up in our calculator or on Desmos. I have it already set up on Desmos for us right here. So I did 2 minus, did this integral. Be careful because in Desmos you can't do this to the third power. If you notice, you got a little bit of an issue here. It only supports the squared and the -1. So make sure that you have this all wrapped up to the third, but you're going to get a final answer of 1.415. Or rounds up to 6, and we're good to go right there. Okay, and for our last part here, this is a BC only question, and we do have a calculator here. So if you're an AB student, you can kick on out of here. But for BC here, we're talking about the RB, the region, and the first quadrant bounded by the graphs of F and G. So if I were to quickly sketch those, this is graphs that are super easy to sketch. ln of x looks like this. This parabola goes through 1, which is where ln goes. So really, I'm looking at this little region, purple region right here. I'm looking for the perimeter around that region. So I need to know the length of blue in that region and the length of red. So we actually need to do our arc length formula. Our arc length, AL, arc length formula is the integral from a to b of the square root of 1 plus the derivative squared. So that's what we need to do. So I've already done a lot of this stuff already. A lot of the heavy lifting is already done over in Desmos. So I have pretty much everything on here. So I graphed this. In this case, this is gonna be green, so that I'll make this match up. What was that one? So red and then blue. So I'll make this one red. Oops, I don't know what I'm doing anymore. There we go. I swear I know how to do this stuff until I'm doing it in front of the camera, and then I feel like I don't know what I'm doing anymore. Okay, so pretty much we need to figure out where these intersect. So these intersect right here at 1, 0, and they intersect right here at this really ugly number. All I did was click this little button right here. It makes that pop up, and then I just made this equal to A. Actually, I can get more accurate than that. I'll have A equal this. You can just do your hotkeys for copying and pasting. And then what I did is I did the first integral there, which is integral from 1 to a of the f, which is red. So we're going to find the arc length of red right here, and then add that right over to this g1 right over here. You can kind of see I typed everything incorrectly. You're going to answer of 1.904, and that is going to match up with one of our answers right here. And that is going to wrap up our video here.